Yeah, hello. And today we'll be diving much about the electrical classification in the process industry. And my name is Emmanuel Adai, a senior process safety consultant from Sigma-HSE. So first of all, I'd like to give something about my background. I am a chemical engineer by trained as a bachelor and a process safety engineer in master's and PhD in process safety engineering, and also hold MBA in engineering management, certified process safety consultant, and also certified safety consultant and certified fire and explosion investigator. And with my background, most of my experience covers combustible dust, electrostatic hazard assessment, and also area classification. And I also do most work on process hazard assessment, PSM, process safety management. And I'm also adjunct professor at Sam Houston University, where I support senior students, teach courses such as incident investigation, process safety, and industrial hygiene. So I'm happy to be your instructor for this webinar, and I hope you guys will get more knowledge about area classification. So for Sigma-HSE, we have three main offices. We have the US or North American office in New Hampshire. We have the Winchester, which covers UK and Europe, and we have the Asia area, which covers India. And we also have two ISO accredited lab. We have one in UK, and the lab in UK actually serves the US location too. And we also have a lab. So with today's presentation, we will be diving more into hazardous area classification. And initial, I'll present introduction into why the need to classify various equipment and also various legal obligations and code and standard which are applicable to the US system and also the European system. And after that, I'll dive into combustible dust classification, highlighting on the basic fire and explosion conditions, and also I'll jump into the classification for gases and vapor. So the first question that comes to mind when you are thinking of area classification is, why are they concerned with electrical apparatus? And the photo on my right actually shows everything. So you can see we have a motor, we have dust accumulation everywhere. So the first thing here is the arc or spark occur under normal operation. That's something that we know. Normal when equipment is moving, operating, it creates an arc or spark under normal operation. And this arc or spark usually can generate an energy up to 1,000 millijoules, and this could ignite a dust cloud or dust layer. Also, consumption of energy produce hot surface. So as you can see, normally during operation, as equipment consume or energy is being consumed, it generates heat. Sometimes it could be frictional heating, and which can actually serve as a source of ignition in the industry. And malfunction of equipment, such as overheating, maybe of bearings. So if you don't have proper maintenance system, and this overheating of these bearings can actually serve as a source of ignition, create a hot surface, and this could also create a source of ignition to ignite combustible dust or vapor in the industry. And usually, if you also don't select appropriate equipment, each appropriate equipment has their own temperature rating. So if I know maybe the properties of my material, I'll be able to select the appropriate equipment for that specific area. And we'll be diving much into the selection of various equipment. And also classification actually was developed to optimize equipment selection. And as I mentioned right now, the goal here is to select the appropriate equipment for a specific area. So the general purpose for hazardous area classification is actually to minimize the likelihood of ignition. If you want to get fire or explosion in industry, one thing that needs to be considered here is the ignition source. So you could have the fuel, you could have the oxygen in the system, or you could have explosive atmosphere, which might be present in the area or the process environment. However, without ignition source, this material cannot ignite because the combustion operation or process will not actually be complete. So one thing that we need to always consider here is to always have a way to minimize the risk of ignition source or to reduce the likelihood of ignition source associated with electrical equipment in the industry. And there are several ignition sources or which can create spark or hot surface from equipment. First of all is the motor or pump or agitation or mixer. During these operations, this material or this equipment can heat up or can generate spark from this kind of operation. And in the presence of explosive atmosphere, that spark or hot surface can actually serve as a source of ignition. The next aspect is fan or blower. So as the fan it moves or blower, it can also create spark, and also it can also have frictional heating. We have the plug-in equipment and receptacle. Sometimes it needs to be, maybe in case you use it in a dust environment, dust can actually go into the system, create a short circuit, and now you can get maybe something that is going to serve as what energy that will be able to ignite such material. We have powered instruments and so on. These are some of these equipment that are used in the industries which actually needs classification. So what about the legal consideration? The first thing that comes to mind is the National Electric Code, that's the NEC, that is the NFPA 70, Article 500 to 502. And this guidance or this code actually contains some guidelines which actually give us the steps by step on how we can actually classify flammable atmosphere, such as gases, vapor, combustible liquid, fibers, and so on. And also the OSHA also has a section in the 29 CFR part, and as you can see, 1910, that's 307, and also it also highlights much about selection of electrical equipment in the various explosive atmosphere. So that means the OSHA actually highlight on it, and National Electric Code highlight. So it's something that needs to be enforced in the industry. The NFPA, that is the National Fire Protection Agency, also main standards that actually regulate or show us ways in which we need to apply this classification in the industry. So we have the 497, which actually focus more on the classification of flammable liquid, gas, and vapor. And we also have the 499, which focus on the combustible liquid and combustible dust and fiber. So these are the various standards that are actually applicable. When we go to the Europe, we have the ATES standard. So first of all, we jump into the combustible dust section. The needs to classify combustible dust, the various conditions that could actually trigger a combustible dust explosion. But first of all, let's try to understand why classify combustible dust. The first thing here is combustible dust can explode in a form of a cloud. That is something which is very, very common in the industry. When you have a dust cloud, we have oxygen, we have the right amount of confinement, we have the suspension of this material, and ignition source. Automatically we can have dust explosion, and about 70% of the materials that we handle in the process industry are actually combustible. The second aspect here, spark and arc in electrical equipment can actually ignite a dust cloud. So spark can generate an energy up to 1,000 millijoules, and most ignition energy or minimum ignition energies of these dust are less than 1,000 millijoules. So having the right concentration of dust in a cloud form and with any spark from electrical equipment can actually serve as a source of ignition and ignite the material. And also sometimes you have equipment which maybe they are not rated well and it generate heat. You have dust accumulation on this equipment can actually ignite the material to get a fire hazard. So that is something that needs to also be addressed. So what is the condition for dust to actually occur? The first dust explosion to occur. The first thing that comes to our mind is dust explosion or dust fire is what? A fire hazard. And normally, in order for fire to occur, you need three main things. You need the fuel, we need the oxidant, we need the ignition source. So that is the fundamental for any combustion operation to occur. So the fuel could be the starch or sugar, and if you all know imperial sugar situation where there was a sugar dust explosion where killed 14 people, injured a lot of people, caused damage worth over millions of dollars. And also we have oxygen in the air, which is always available unless you decide to exclude oxygen by inerting, by introducing nitrogen or argon into the system to replace the oxygen. If you don't do that, that means the oxygen is always available. Also have ignition source, which could be the spark or electrostatic discharge, or they have almost about 13 various ignition source that needs to be considered. But for this presentation, you're going to consider more into the spark or hot surface from electrical equipment. So for combustible dust explosion to happen, the initial one was for general fire. For combustible dust, we need to have the fuel, which is very, very important, which is maybe sugar. Then we need to have oxygen in the air. We need to have ignition source. If we have the fuel, we have oxygen, and we have ignition source, we are going to just get fire. So that is the normal fire triangle. However, if we have a dispersion, so now we have four. We have fuel, we have oxygen, we have ignition source, we have dispersion. In this case, we are going to create something called a flash fire because we don't have a confinement that is actually going to retain the heat or energy release in the system. However, in case we add the fifth element, that's confinement, such as a bag house or maybe a silo or a bin, in this regard, all the frame or the energy or the heat which will be released from the combustion operation is going to be retained into the system until the pressure wave or the pressure which will be released is more than what the material or the equipment could handle, then we could have explosion. So these are the conditions that could lead to dust explosion. One thing which is also very, very important in the industry is what secondary explosion. Secondary explosion happens when you have the first explosion and maybe there's a lot of dust accumulation in the operation where this dust from the first explosion, the heat release or the energy or the pressure wave will shake the whole system, letting the dust to fall down. Then the flame from the first explosion will actually ignite that dust cloud. Then you can have a secondary explosion. Secondary explosion are actually much intense and much devastating compared to the first explosion, because in this case it involves a larger volume, a larger amount of dust in the whole system. So the National Electric Code has some groups, have actually grouped some of these dust that we handle at various industry. So normally, in case I come to your facility to do classification of your equipment, the first thing that will come to my mind is what type of material do you handle? What kind of group does your material fall in? So the NEC actually gives three definitions of three type of groups for combustible dust. The first group is group E, which actually focus on combustible metal dust, which could be aluminum, titanium, magnesium, various alloy, various kind of steels that we handle in the industry. So all of them falls under the group E. We also have the group F. The group F focus more on the carbonaceous materials such as coal dust. We have also the carbon black, charcoal, and so on. So all those carbonaceous materials all falls under the group F. And the group G are the most common material. So any material which does not fall under the F or E, all of them are grouped into the G. So which could be wood, flour, plastic, and other chemicals that we use in our daily life. So usually if I classify equipment, I need to add the group of which that classification needs to be. So I have this table here just to help to distinguish various classes and divisions compared to the North American system and the European system. So in North America, we have North American we use classes, and in the European they use the zones according to the attest. So in North America, we have three main classes. We have the class 1, which actually focus on the gases and vapor. We have the class 2, which focus on dust. And we have the class 3, which focus on the fiber and fines. So that is something that we need to always understand. So if somebody indicate, okay, this is a class 1 area, then our focus needs to be on gases and vapor. If I tell you, okay, this is class 3 area, then something that needs to draw your attention here is, okay, you are handling what fibered material, or maybe class 2, which is maybe dust. And also, when it comes to the Europe, we have the zones. We have the zone 0, the zone 1, zone 2. All of them falls under the gases and vapor. And we have the zone 20, 21, and 22 are combustible dust. So unlike the American system where they separate the dust from fiber, in the European standard, they actually combine the fiber and the dust into one specific group. That is the zone 20, 21, and 22. So all of them is dust and fiber. And also in American system, we also have the division. So if there's a class, we have two divisions. We have division 1 and division 2. Division 1 focus on when there is a presence of maybe explosive atmosphere or ignitable atmosphere, usually under normal operation. For example, if maybe I have a bag dump area, where during dumping of material always I create a lot of cloud, or maybe inside equipment. But in the American, in the North American, we don't actually classify inside equipment. But in the European standard, they classify inside the various equipment. Also, we also have the division 2. The division 2 focus on maybe you could have explosive atmosphere, but not under normal condition or operation. Maybe under abnormal condition, you could create a dust cloud, or maybe a gas vapor could be released. So this is the various differences between the various European standard and American standard, and knowing the various classes and also the divisions and also the various zones. So first of all, for that, let's go to the class 1 division, class 2 division 1. So if we mention class 2, automatically what comes to our mind is what combustible dust and division 1 location. So a location, division 1 location is a location where combustible dust is in the air under normal operation condition in a quantity sufficient to actually produce explosive or ignitable mixture. So what is ignitable or explosive mixture? Where we have the right concentration of dust and right concentration of air combination that could actually ignite, or where the material combination or the concentration is actually above the minimum explosive concentration. Minimum explosive concentration is the least amount of dust in the air that could actually ignite. So that is what is termed as the explosive mixture or maybe ignitable mixture. Or when maybe mechanical failure of or abnormal operation of machine equipment might actually cause explosive or ignitable mixture. So maybe under normal operation, you are not expecting to get this explosive atmosphere. However, under abnormal situation, And usually I consider this to be maybe you have a system, or maybe let me use a back dam area again. Sometimes you try to dump the material gradually, but what happens when there's a big spill? In this case, you create a very dense dust cloud of which, or maybe you have a dust collector where the bags actually breaks. You create a lot of dust cloud there, or you have equipment where maybe the hose actually disconnect. It can create a dust cloud. I went to a facility where they have uh, various hoses for transfer of material, and the hose actually came apart, and they created a lot of dust cloud and dust layer where they actually got into fire hazard. So in this scenario, under normal operation, this was something not to be expected, but under abnormal situation, that it created such a hazard. And also, when anywhere there's a metal dust, is always a division 1. So metal dust, there's nothing like a division 2. So if you handle aluminium, or maybe titanium, or zirconium, or steel, or iron, any kind of metal dust, automatically you will be classified as class 2 division 1. What about division 2? Division 2 is where combustible dust is not normally in the air in a quantity sufficient to produce explosive or ignitable mixture. So under normal situation, you are not expected to get dust cloud that can produce explosive mixture. However, under abnormal situation, you can create that. And also where there's a dust accumulation are present, normally insufficient to interfere the normal operation. So you could have a lot of dust accumulation there. And as I mentioned in the first, as I mentioned in initially, usually dust cloud can actually happen when you have a dust layer which is being disturbed. And usually this can create a secondary explosion. So dust accumulation having at a sufficient amount can also, and I'll go to have a table to explain this, can also lead to a classification of the various area or equipment. So which areas could be considered as unclassified? So the first one, areas where material are stored in sealed containers. So if you have any area where the material are stored in sealed containers, such as the bags, drum, fiber pack, or pallet, or rack, so far as they are sealed in their various containers where the material are not released to the immediate area or environment, are always considered as an unclassified area. Where areas where material are transported in a well-maintained closed pipe. So you have pipes where maybe pneumatic conveying pipes where the materials are actually in their sealed container on sealed pipe, you don't need to classify it. And also area where characterized material with minimal dust, so where you don't create any kind of dust in this kind of operations, you don't need to classify such area. And where a cruise tank or storage building, you don't need it. And where maybe you are able to clean the dust where you cannot actually use my hand. Normally when I go to various operations, I use my various hand to actually clean, to see if I can write my name. If I can write my name, then I say, okay, you have enough dust cloud. Or where you don't have a lot of dust there, which is less than 1/32 of an inch. In this case, you could actually consider the place as unclassified. And where you have a housekeeping, because normally in the various warehouse, you don't generate any kind of dust. Various production area, you don't create a lot of dust. Where normally you create a dust is where you have various blending operation, powder transfer operation, maybe you have sifting operation area where you could have dust actually coming out from the operation. So this is the table I was talking about. So we can also use dust accumulation level to also classify an area. We have division 1, which is when the division is greater than 1/8 of an inch, and between 1/8 of an inch to 1/32 of an inch, you can classify the area as what, as div 2. and where you can't see any dust in the area, or maybe less than 1/32 of an inch, you don't need to classify the area. I brought a typical example where I copied from the NFPA 499 to show you the various levels of classification. Where we classify as class 2 div 1, usually where we think that dust cloud in specific quantity can form maybe explosive atmosphere. Usually the classification is 20 feet from the source of maybe explosive dust cloud needs to be classified as class 2 div 1. So that is the number, 20 feet. So we assume that within 20 feet, this dust cloud, maybe in case there's any equipment, the material can actually travel, or the cloud could actually travel, which could actually serve as what explosive atmosphere. And if you have an overrated equipment, we can generate spark or arc, it could actually ignite such material. And also beyond the class 2 div 1, then you can classify as div 2, and div 2 is always 10 feet radius from the source. So that is how the numbers are actually given in case you want to classify equipment. But one thing that needs to be considered here is, do I have explosive atmosphere? Do I have the right amount of dust cloud in the air, or maybe dust layer which is more than maybe 3 millimeters or something like that? And also, in case maybe you want to classify an area as class 2 div 2, is always 10 feet. So that is something from the source. So if it is a back dam area, then you need to consider 10 feet radius from the source. And for maybe for unclassified, from the source, you don't need to classify from the whole system there. So what are the various type of equipment that needs to be installed? So normally when you consider the div 1, then you can consider NEMA 9 type of equipment, and I show a picture of NEMA 9 type of equipment here. So it's always used for enclosure constructed for indoor use in hazardous area, located in maybe class 1 div 1, and it could be group E, F, or maybe G. And division 1, you also have metal dust into that, because all metal dust falls under division 1. And also when it comes to the division 2, then we can consider also NEMA 4, NEMA 4X type of equipment. And normally you have your equipment and it's always rated, they write those equipment there. So if you think that your area, or you know that your area is generating a lot of that dust cloud in air that could actually serve as a source of maybe explosive atmosphere, then you need to know what type of equipment that you'll be selecting. And usually when I do area classification, normal for combustible dust, I tell people the only way you can prevent, maybe usually for dust accumulation side, is the only way you can prevent is to make sure a place really tidy, because these type of equipments are super expensive. So if there's a way you can keep the place clean, that means it's always the best. Or if there's a way that you can actually keep the dust from coming out to form explosive atmosphere, then you need to do that. Or if there's the way that you can install a local exhaust ventilation to capture the dust into a dust collector, then you can do that. And there are also temperature rating of equipment. So temperature rating is, first of all, you need to know the various ignition temperature of this material that you are handling. So if maybe you have for a dust cloud, maybe the material you are handling, the ignition temperature is 300 degrees C, then you know that, okay, that means I'm going to select equipment which is sort a T2 type of equipment. And the producers of this equipment understand those things. And also we have layer temperature, where based on the surface temperature of the material, of which we can determine all these ignition temperature in our lab in UK, where we can do all these tests. So based on the ignition layer test or ignition cloud test of ignition temperature of cloud or layer, we will be able to select the appropriate equipment for your facility. What about combustible liquid, or maybe liquid or gases? Usually you still need this triangle for maybe ignition of a cloud of mist or vapor or maybe gases. You need the fuel, which could be maybe your natural gas or maybe toluene or any kind of combustible liquid or maybe flammable liquid that could be present at your area. You also need the oxidant, you need the various ignition source. And normally for liquid, you need to know the flash point, because if maybe the flash point is maybe above maybe the atmosphere or the operation temperature, automatically you're not going to get a vapor which is going to ignite. We need to know the flammability limit of this kind of material to know whether the amount of gas or vapor that is going to be released into the environment is going to be within the flammability limit range or explosive range. And also we need to know whether we have sufficient oxygen. And as I said, in case you don't exclude oxygen from the operation, automatically you are going to actually get oxygen in the air. The way to exclude could be maybe nitrogen purging or argon or carbon dioxide. If you don't do that by inerting, that means you always have the oxygen available in the system. So as I said, I just presented some flashpoint of various materials, and for liquid, we have various classes. We have the 1A, where maybe the flashpoint of the material is less than 73 degrees Fahrenheit. We have the 1B, we have the 1C, and we have class 2, class 3A. And so all these are something that we need normally in case before I come to our facility for classification of flammable liquid, I need to know this, to know, okay, what is the, under normal operation, are you going to create a cloud of vapor in the system, and also I need to know the auto-ignition temperature of these materials. So how do we define class 1, division 1? As I said, class 1 is always flammable gases, vapor, or liquid. So division 1 is where you have explosive or ignitable concentration of flammable gases or liquid that actually produce vapor, because liquid in its pool form not going to actually get any explosion hazard. It can burn at the surface. That's why we need a flashpoint. But in the vapor form, it can easily actually ignite. So where these liquid or gas or vapor actually exist under normal operation condition. So where maybe they have an open system where for liquid where they have a sampling point, and this kind of operation automatically will generate vapor under normal operation. And also where you have a concentration liquid, so when you have liquid that is always above the flash point under normal operation, and in this case you could actually create a div 1 environment. And also when we know that breakdown of faulty or process might release ignitable concentration of vapor. In this case, if we are certain that, okay, in case something happened to this system, automatically we are going to create an explosive atmosphere. That means we need to also transfer the place as div 1. What about div 2? Div 2 is in which volatile flammable gases or flammable liquid are handled, processed, or used, but in the liquid or vapor will not normally be confined within a closed container. So normally, in case the place is an open environment, or maybe under normal operation, you are not going to create explosive atmosphere. In this case, you know that number one, okay, this is something which is happening. There's a possibility of generating material, but to create explosive atmosphere because of maybe a good ventilation system which is going to exhaust the material into the atmosphere or into a system, or maybe you will never get maybe explosive atmosphere under normal operation. However, under abnormal operation where maybe the system could rupture, where maybe you will have the flanges, various valves. In this case, in case there's any abnormal situation, you're going to have a leak of gases or vapor. And in this scenario, we can classify the place as div 2. and also in which there's a positive mechanical ventilation. So in case you have positive mechanical ventilation, that might become hazardous through failure. So sometimes we control various flammable atmosphere in the industry by using maybe positive ventilation system, and which could actually reduce the amount of material cloud or vapor that is going to actually generate into the system. However, in case that ventilation system, the fan or the blower breaks down, you're going to have explosive atmosphere. In this case, we have to still classify the room as or the area as div 2 and so on. So let me move to the next one here. So where do we classify an area as what as, or how do we consider an area as unclassified? So where you have adequate ventilation is provided, where combustible material are contained within suitable or well-maintained close pipe. So number one here, you could have a really good negative ventilation system, a good ventilation system, where you believe that automatically you are not going to have any kind of dust cloud or gas vapor in the system. Then the place should not be classified. And also where you have a well-maintained closed piping, where there's always a pipe, where there's no flanges, there's nothing which is going to burst or maybe release any kind of gases or vapor. In this case, we should consider the place as unclassified. And also adequate ventilation is lacking, but where piping systems are without valve or fittings, as I mentioned initially, where maybe you have no fittings or maybe flanges or similar accessory that may be prone to leak. In this case, you don't need to classify the area. Where combustible material are stored in containers. So for example, in case you store combustible materials in a sealed container in a warehouse, that means you don't need to actually classify, because even if there's a release of this material, you're not going to have a vapor pool because they are below the atmospheric temperature. So you're not going to have a vapor above the atmospheric temperature to create a cloud. So, and also location where the use of combustible liquid or gases will not actually produce a gas or vapor sufficient to reach 25% of the lower flammability limit. So normally in case some processes, they have concentration meters there to determine the flammability limit. And if the operations is maybe a risk assessment has been actually been done, and we know that the concentration will never actually exceed the lower flammability limit, then in this case, we don't need to classify the area. So what are the various type of protection or intrinsically safe type of equipment or installation that we need in the various flammable atmosphere? So the first one is 4 to 20 milliamp DC instruments. So these kind of equipment are actually intrinsically safe. Two wire transmitters, we have various thermocouples, and this kind of equipment are naturally come as what intrinsically safe, that actually is not going to create a spark or maybe a hot surface that is going to ignite various materials. And also we also have various kind of equipment. So we have the division 1, we have explosion proof equipment. So explosion proof equipment are equipment that is actually tight enough to prevent any kind of vapor or maybe gas to penetrate into the system, or maybe it's not going to actually generate a spark or arc. And also we have intrinsically safe, as these are the intrinsically safe equipment. And we also have purge or pressure, and also NEMA 7 explosion proof equipment. So all these type of equipment can actually be used in a division 1 area, that's class 1 division 1 area. And also for division 2, we also consider any equipment which is suitable for the division 1 area could also be used for division 2 area. And we have various, we have non-sparkling, we have non incentive type of equipment, and we have NEMA 7, NEMA 6, and so on. So all these type of equipment can also be installed in a Division 2 areas. So how do we also classify a division, a class 1 area? So for class 1 area, where we have the source, so let's consider the picture on my right hand side here. You can see we have the source here, and with the source, normally we consider usually 25 feet on the horizontal, and normally the vertical is always 3 feet. So this is how actually we kind of classify various areas. So it's always the source is 25 feet from the source, and always if it's liquid, normally it's supposed to be 3 feet from the ground. And also if it is also division, and always after division 1, we need to always do division 2. So let me come back here, and this is a diagram I picked from the NAPA 497. So we have a source here, and with the source here, we for division 2, we have 10 feet from the source and 3 feet from the source to the top. So that is how we classify flammable solvent or vapor. And normally a lot of factors actually influence it, and there could be also pressure factor in case maybe the material could be pressurized. That means you could actually, the extension of classification is to go far. And also if it is normal atmosphere condition, then for example, this is atmosphere condition. In this case, you need to actually have the normal classification. I have another typical example also here, where you have an enclosed system, and you can see that you have a process equipment, it's slow pressurized and moderate in flow rate. So in this case, 25 feet from the source, and also you have 3 feet. And if the material the source is elevated, you can actually go 5 feet above it. And also if it's also in elevation system on the right picture, you can see how it's being actually classified. Usually it goes 25 feet from on the ground, and usually either 3 feet or 5 feet. Yeah, so I think that brings us to this. I know that people have questions, so I wanted to cut things short so that we can have more discussion. That brings us to today's webinar. And we have a full training, maybe 2 days full training on area classification. Webinar is just to give a general overview of classification, to understand the various divisions and also classes, and the type of materials that are supposed to fall under various division and classes, and also the various type of equipment. However, in case you want more details with various examples and detail on classification, how we go about it, that one we can contact us direct, and it can take a whole day to do this. So this is just a general overview, and thank you very much. And in case you have any questions, I'll be available to answer any question here. And I think there are some questions here that we need to I need to answer. So the first one here is from Estelito Ragels Jr. Okay, and he said, is it possible to consider an area with stored material as Division 2 because there is possible of release of such material by accident? So that is true. So yes, if there is possible release, so the point here is possibility. If you know that maybe there is a way, or maybe the material can actually be released, or maybe dust cloud could actually be formed, in this case, yes, you can actually classify. But where the material is in their sealed containers, where you know that, okay, maybe I have the material in super sacks or maybe various bags, and in this case, if they are in the sealed container, there's no way maybe it's going to burst or something like that. That means you don't need to classify. But if you are 100% sure that, okay, this is something you have seen before. I've even been to an area or operation where some part of a warehouse are classified because I saw a lot of spillage of dust there. Even though warehouses are not supposed to be classified, but based on my observation, I told them to classify the area. So it all depends on the type of operation. If you are 100% sure that, okay, based on maybe the way we handle the stored material, there's always a lot of dust which is being released, or forklifts keep punching the veilous bags, then we need to classify the area. But under normal circumstances, in a sealed container, we don't need to classify. And the next question here is it valid and safe for all? Yes, so normally for combustible dust, one would say 10 feet is enough from the source. And yeah, because if maybe I handle, because I handle various dust or gas, where maybe dust I do powder transfer, powder dump into maybe a bin. In this situation, beyond 10 feet, I don't think you are going to create a dust cloud, a thick dust cloud. To have a dust cloud which is within the explosible range or maybe above the minimum explosive concentration, you cannot even see the next person usually. So 10 feet, within 10 feet is the mark. Beyond 10 feet, I don't think you are going to create a explosible atmosphere unless a secondary explosion falls in. As I mentioned, a secondary explosion is maybe in case you have dust accumulation all over, but in case you have a dust accumulation all over, that also triggers actual classification itself into the whole room or the whole environment. But for dust cloud to form during maybe a normal operation, maybe sifting operation, or maybe powder transfer operation, usually within 10 feet is what is always recommended. Okay, the next question here is, what if you have both combustible dust and flammable liquid? Which hazard classification? So yes, for hybrid atmosphere, that is very, very important question here. For hybrid atmosphere, you need to, usually this has been a very tricky question there because some of the equipment that can be used for dust cannot be used for gases. And some of the equipment which can be used for gases cannot be used for dust. So usually I would say that usually most of the equipment which can be used for gases can actually be used for dust. So I'll go with the worst case scenario. And gases are easily to ignite. And also, if you have gases easily to ignite, then you must ensure that those equipment are also dust tight to create to prevent any short circuit. So usually I'll go for the worst case. However, I also take that into consideration before, because gases cannot create a short circuit, but for dust can create a short circuit because the dust will enter into the system where it can create. So that is something that's yeah. Thank you for that question. Yeah, I've seen these kind of questions in the various industries where people do ask these questions a lot. The next question regarding class 1 division 2 is 25 feet used for any pressurance of the process. Such figures do not inform the pressure involved. No, that one we actually need to actually evaluate the system. So we need to actually know what is the type of pressure in the system and what is, in case there's a release, what is the jet which it can actually move. So these are all the things that needs to be considered during the area classification. A lot of calculation also needs to go inside to understand what is the length of which this can actually go. Because usually, based on this discussion, we cannot actually tell you go and classify your area as this or this, but a lot of thought actually goes into classifying various equipment, and various parameters, various data are actually needed. And before I come, then I need to know maybe list of various equipment. And normally for gases, I need to know the pressure at which you operate. I need to know the the flash point of the material. We need to know the temperature of the minimal ignition temperature of this material, or the auto ignition temperature. So I need to know all these parameters to prepare to understand the operation before we do it. So this training does not actually automatically say, okay, now I have enough knowledge to classify my area. No, there's a lot into it. This is just a webinar which is trying to introduce what are actually the hazard associated with it and how we go about it. But in case you want to know much about it, we can organize a detailed training, maybe 2 days training, where it will give more examples, more case study that we can actually do. Any question again? Yeah, Jennifer, I don't know whether I was able to answer your question. And Estalito, thank you very much. And any question, I think we have more time. Usually, I wait until the latter part. This time I decided to at least 15 minutes for questions and answers. So we still have some few minutes for some questions. And if you have any question, you can also contact us directly, and we can answer any questions that you have. Okay, so if we don't have any questions so far, then thank you very much for joining this webinar. You can contact us anytime. You can contact me directly by my cell phone number, and we can discuss more about your operation. We have a team. If you need to be trained directly, we can do that. If you need your area to be classified, we can also do that. And in addition to that, we also have various services that we provide, such as consulting, preliminary hazard assessment, DHA, dust management, gap analysis, electrostatics. We do all these assessments. We also have a laboratory where we do various combustible dust testing and understand. So thank you very much, and you end this webinar. Thank you.